In the last video, we have already discussed about one-hot encoding. Now let's go through the code. So here I am importing NumPy and pandas, and then I'm reading one-hot.csv. This is some random data set that I have generated, in which there is brand column, and then owner column, and then fuel column, and finally I'm having the output column that is selling price. Okay, so if you use df.head, you can see what are all the columns available and the selling price. So here, if you see, it is taking the column or the row index as some extra column. So if you wanted to remove any specific column, we can mention like this. So here I wanted to remove the first column. So that's why I'm giving df.columns of 0. So it will be giving the exact column name. And then I'm mentioning access equal to 1, which will represent that we need to remove one specific column. And we are doing it in place. That means there is no need for us to assign to df again. So if you are directly using in place equal to true, it will do internally and it will remove. And after that, if we observe df.head, now we are able to remove this column, right? Now we are only able to observe these four columns, that is brand, owner, fuel, and selling price. Okay. So on this data, like we wanted to apply one hot encoding. And for suppose, let's not look into which one will come under one hot encoding and which one will be going on to some other encodings. Now let's try to do one hot encoding on all these things because we are interested in understanding how to apply one hot encoding. Right? So let's apply one hot encoding on everything. So before going on to that, like let's say sometimes within the column, what are all the distinct values and how many times it got repeated, that information, if you wanted to know, that you can know using this particular value counts. So here what I'm doing, I'm using df and then I'm selecting the column that is brand, and on that I'm using this value counts. And if you observe, it is giving what are all the different values available in this brand column, that is Toyota, Audi, Chevrolet, Renault, like that, different brands available in this brand column, and how many times it got repeated in the whole data set, that information. Like that, we are having all of this information related to brand column. And if you wanted to check what is the number of unique values in that specific column, then you can simply use this n unique. And by observing this, we can clearly know that there are 22 different values in the brand column. That is, the number of different brands available are 22. Okay. And similarly, we can do that on owner column and fuel column and all these columns. Okay. So in owner, there are three distinct columns and each got repeated these many times. Whereas in case of fuel, we are having four distinct types of fuels like petrol, diesel, LPG, and CNG. Now, there is one simplest way to do or apply one hot encoding. That is, like it is an internal method to pandas. In that, we can use this get dummies, and to that we can mention or specify what are the columns that we wanted to one hot encode. So here I'm mentioning fuel and owner column to be one hot encoded. Okay. Now, if you observe, my data frame changed like this. Previously, it used to look like this, that is brand, owner, fuel, and selling price. Now, if you observe, it is changing it like this: brand, selling price, and then fuel. How many distinct fuels we have? We have four distinct fuels, and for each of the fuel, we are having a separate column. And whenever we wanted to represent one specific value, like let's say the first one is diesel. So here, if you observe, what is the first value in fuel? That is diesel, right? So how it is representing it? It is keeping true in place of diesel, whereas in remaining places it is keeping false. And similarly, in case of owner, the first one is third owner, and that it is representing by keeping true over here, in remaining places false. Like that, my data frame got changed. Previously, I used to have only four columns, including selling price. Now, total we have nine columns, right? So brand, selling price, and four are of fuel and three are of owner. Okay, like that we can apply simply this one hot encoding technique. And there are some other ways to do that as well. So before moving on to that, let's split our data. So in order to split our data, we can simply use this train test split. And here we are passing our input columns that are 0 to 3. Basically, this will not directly change the data frame. It will just return this particular data frame. Okay, so it is not affecting df as of now. So that's why we are directly taking first three columns of df. That is, what are the first three columns? That is brand, owner, and fuel. So those I'm taking as input columns, and the last column as output column. And I'm mentioning test size to be 0.2, which means that 20% of the values will be going into the testing data set, whereas remaining 80% will be going into the training data set. Okay. And you can observe the shape of X train. So that is 5600, 3. And similarly, shape of x test, that is for 1400, 3. Okay. And this is the second way of applying one hot encoding. From SQL or preprocessing, we can use the method that is one hot encoder. And here there is something called as drop first equal to true, and there is parse output equal to false, and d type equal to np dot int type equal. Basically, this d type is simple. That is because here, if you observe, we are having Boolean values, right? Instead of Boolean values, if you wanted to represent 0 or 1, we can simply use this d type np equal to integer. And sparse output is like if you have idea about sparse matrices, sparse matrix representation, like in general, what are sparse matrices? Sparse matrices contains lot many zeros, and that we can reduce and we can store it in very less space. So that kind of representation can be used in order to represent over here, because here if you have, see, there are a lot many zeros when compared to ones, right? So short form of representation can be used, but as of now we don't want that, so directly we are keeping it as false, and we are using drop first equal to true. So in some time I'll discuss this as well. Okay. And what we are doing, we are using this one hot encoder and we are fitting it on the in all the input columns that we are having. Okay. So basically here we are not using all columns, we are using 1 to 3. That means honor column and fuel column will be selected, and on them this one hot encoding will happen. Okay. So what does fit do? Fit will just analyze and do some mappings. So like here it will map, like it will think that there are four owners, and in sorry, there are three owners, and in fuel there are four distinct columns. Like that, all the analysis will be done on the provided input columns, but it will not change the extraint directly. And similarly, after that, we'll use this transform. This transform directly apply the analysis or apply the things that it has to do. And after applying, it will return the data frame, or it will return the numpy array of it. So after applying this transform, we'll be getting some numpy array. And here, if you observe, this numpy array is having 5 columns. Okay, but what is the expected number of columns that we wanted? In owner, how many distinct values we are having? We are having three distinct values, whereas in case of fuel, there are four distinct values, right? So total number of expected columns should be seven. But here, if you observe, there are only 5 columns, right? And why is that happening? That is happening due to like this drop equal to first. And what this drop equal to first is doing, so what it will do is, let's say this particular city column, I am having 5 columns, right? And why is that five? Why is it having 5 columns? Because there are 5 distinct values in the specific city column. So instead of representing it like this, so basically we wanted to represent all of them uniquely, right? So if we remove this, even then all these are uniquely represented, right? Like Hyderabad is given 0000, and then Noida is given 0100, and then Delhi is given 1000, and then Bangalore is given 0010, and then Mumbai is given 0001. Like that, all these are uniquely represented, and it solves our purpose to some extent. Like there is some disadvantage due to this if you are leaving out the first one. That is, we can't adjust one extra parameter related to the city Hyderabad if you are removing it out. So that need to be adjusted by this theta naught itself. So the model will should be intelligent enough in order to adjust the missing information of this extra column using theta naught. So that it needs to do it internally. That is extra headache that it needs to carry. But the advantage with this is, let's say we are seeing only one column over here, right? So we might not think that it is that much advantageous, but it can happen that in some data set we have, let's say, 10 columns, and all these are discrete columns. Let's say all these are having some string values, and each are having some 5 or 10 distinct values within each feature. Then all these will be divided into 10 into 5, that is 50 columns we'll be having. So in such case, if you are using drop first equal to true, we can reduce by 10 columns, and we can obtain, or we can like go forward with 40 columns itself, right? So in such case, it will be helpful when there are many number of columns. So in such case, we can simply go for this drop first equal to true. But whenever we are having lesser number of columns, we can simply use, like we can ignore this as well. Okay. So to just tell this is also possible, I'm just showing it. Okay. So what dropper stick will do, it will remove one extra column from each of the columns. So that's why we are having only 5 columns over here. It will remove one from this owner column and the other from the fuel column. And then if we check out the shape, it is 5600, 5. And what is this 5600? These are the number of samples that we are having in the training data set. And then what we are doing, we are converting it into data frame. This is like NumPy array, right? So we are converting it into data frame. For that, like basically here column names we need to specify, right? So in order to get the column names, we can use this specific function that is one hot get feature names. And we need to mention the actual feature names, that is owner and fuel. Then it will be able to generate the names like this, that is owner, second owner, third, fuel, diesel, fuel, LPG, fuel, petrol, like this. Okay. So after mentioning this, here what we are doing, we are resetting or removing the index. So if you observe extract, so the indexes are jumbled, right? That's because while splitting the data, we are using random state, right? So it will jumble up the data set and it will pick random 80% of the data. So that's why all these are jumbled up. So if we don't reset the index, then it will do mapping wrongly. So that's why we are resetting the index. And then we are concatenating this extrain. Sorry, first we are dropping owner and fuel columns because these are the previous columns, right? So these we are dropping, and then we are appending this encoded DF. In encoded DF, we are having the new columns, that is owner, second, owner, third, fuel, diesel, fuel, LPG, and fuel, petrol. So these we are appending, and now my extract will look like this. That is brand and all these columns, extra columns. Okay, this is the only encoded DF. That is this one. So like this, we can get our like one hot encoded data, or simply you can use pd.get as well. And there is some third way. So basically, if you observe the brand column, how many values we are having? We are having so many distinct brands, right? That is 22 number of distinct brands. But if we carefully observe this specific data, so there are almost near to half, or like near to some 10 brands are having count less than 100, right? So these all are having very high amount of count, whereas these are having lesser amount of count, right? So sometimes it can happen that we can merge these less occurring brands so that we can reduce the number of features. So basically, like, why are we trying to reduce the number of features? So here, why are we trying to reduce from 50 to 40? That is because we are trying to reduce the number of parameters internally. Let's say we are having 10 features. Then what will be my number of parameters? The number of parameters will be 11, because this is one extra parameter. And if you count the parameters, the number of parameters will be 11. So if you're having 11 parameters, then the model has to adjust these 11 values, right? So these many values the model has to adjust. If we are having 40 parameters, the model has to adjust 40 values. So the amount of time taken for the model will be very huge if the number of parameters are high. That's why we will try to reduce this as well. Like there will be some trade-off, right? Sometimes we wanted to save time, and sometimes we wanted like accurate answer. So if you really want accurate answer, like we want 99.99% accuracy, and you don't care about the time, then you can do all these kinds of things, like how many hour features you wanted. On all those things, you can apply on hot encoding, and you can directly code that. But whenever we wanted to save time with 1-2% of error, then you can do some techniques like merging all these brands and use lesser number of brands. That we can try. And let's see how to do that. So in order to merge those less occurring brands, what we are doing over here, first we are taking this value counts. In value counts, we are having all these counter of occurrence of each brand. And then we know like what is the unique, or what are the count of unique brands available in brand column and owner column and fuel column by observing this. And then let's keep the threshold to be 100. So let's say we wanted to remove, or we wanted to merge all of these so that we can like have lesser number of features, or sorry, lesser number of parameters. Okay. So in order to do that, I'm using this brand counts, and I am like filtering out the indexes. So this what it will do, it will find what are all the brands which are having count less than 100, and it will find out index of them, and getting all those indexes, and those indexes it will be storing it in this branch to remove. And This branch to remove will be having BMW, Honda, Kia, Mitsubishi, Lamborghini, Nissan, all these brands. Okay, and this will be containing all the names of it. And then we are applying this one hot encoding. We already know how to use this get dummies, right? So in this, what we are doing, we are using this brand, and in this brand, what we are doing, we are replacing like all these brand names. That is BMW, Honda, Kia. Basically, this branch to remove will be having all these string values, right? BMW, Honda, Kia, and all these things. So it will replace those strings with something called as mix brand, and then it will be applying one hot encoding on it. So if you observe, I'm having lesser number of columns over here, and there is something called as mixed brand over here. So this mixed brand is combination of all these brands which are occurring like less than 100 times, whereas remaining will be having their individual columns. Okay, so like Audi, Chevrolet, all these are having their individual columns. So this is regarding one hot encoding notebook. I hope you guys are able to understand everything clearly. So if you have any doubts, please comment down in the comment section. I'll be replying for that. And that's it for this video, guys. Thank you, everyone.